Okay, section 2.5, graphing special functions, part 1. First thing that we're going to talk about here is graphing piecewise defined functions. So before I talk about it kind of explicitly what those are, let's take a look at this graph right here in the first box. What would the function that generates this graph look like? Well, a couple things we can see about this function or this graph. It's made up of two lines. In fact, it's made up of the parts or pieces of two lines. So maybe it's like half of this line and like half of that line, okay? So how would we write that? Well, this line has a y-intercept of -3, and it has a slope of -1, okay? So it's difficult to see, but it goes down 1 over 1, so it's got a slope of -1. So that first line is y equals -1x, so -x minus 3. The second line here is y equals x, I think. It's got an intercept of 0 and a slope of 1. So it's y equals x. So it's part of each one of these lines. And so you might say, well, which part is it? Well, this line only exists when x is less than 0. And this line right here only exists when x is greater than 0. Or greater than or equal to. Actually, if it's equal to 0, we have got a solid dot there. All right. So this is a perfectly legitimate function. It passes the vertical line test, right? It's got this line segment over here on the left, line segment right here on the right. So the question is, well, how would you write this function? The way that we're going to write that, the notation we will use, is we will use this great big brace, or bracket, and we'll write the first part of the function, so -x minus 3. And then we'll leave some space, put a comma, and then we'll put only when x is less than 0. Okay? And then we'll take the other function, the other line, and we'll say, well, that's x. And then, but only when x is greater than or equal to 0. Okay? So this function right here would graph this. Right? So let's try and go just from a given function and see if we can get to the graph. You should give this a try on your own, by the way. So try this on your own first. These are lines, but you could use so they're not difficult to do by hand, but you could use your graphing calculator to get a picture of them too. X minus 2, so that has a y-intercept of -2 and a slope of 1. So down 2 and a slope of 1. So it will look kind of like this. I don't want to draw it in too thick here, all right? And it's only when x is less than -1. So I go to -1 and I see that, okay, this graph is going to pick up here, and it's going to be an open dot because it's only less than, so it's not including that point, and then the graph will look like this. Now, I'm trying to do this in pen so that you can see it easily on the camera. The best thing to do is to do it in pencil and then erase the parts that you don't need. All right, but anyway, so that's the first part. So we got that. And then let's go to the second part, x plus 3, x greater than -1. So again, x plus 3 would be up 1, 2, 3. 1, 2, 3, yep, so right here. And then only when x is greater than or equal to -1. So, and it has a slope of 1. So it'll look like this. And be a solid dot here. And it'll go like that. Okay, so that's what the graph of number 1 looks like. Right? Again, you can get that in the graphing calculator. You can take a look at that in the graphing calculator and then only graph the parts that you want. So, in fact, let me show you how you might do that. So, let's go y equals x minus 2. So here's what the graph looks like. Wonderful. But really what you want is the table and you want to pick some points. So you want to start at -1. And then you want to go to the left, right? So in other words, -1, -2, -3, and you can plot those points, and you can get a graph of it. Okay, and you do the same thing with the other one, but you only do the values of 1 or more, -1 or more. Okay, all right. So let's graph this piecewise defined function here. So this one has 3 parts. That's all right. We'll use the same reasoning. So I have 2x plus 3 when x is less than 1, -x plus 2 when x is between 1 and 2, and then I have 3. So that's y equals 3 if x is greater than 2. Okay, so let's piece this together here. 1 appears to be an important value, so I might even just highlight that on the graph over here, that 1 is important, because that's where this graph picks up. So, and you know what, I'll show you how to do it in the calculator just because many of you will probably like that because it's quicker. So we'll go 2x plus 3 graph it. So that's what it looks like. We get the table, and we only want values that are 1, starting at 1. So 1 comma 5. So 1 comma 5, and that's an open dot. I did not give you very much space here, did I? And then the slope is 2, so then we'll go 2 comma 7. Whoops. Sorry, it's up here actually. Whoops. Oh, no. Cresswell, do it right. I'm sorry, we want less than 1. So we're going to go back the other way. Okay, so 1, then 0, 3. And then it looks like I've got, let's see, 1, negative 1, comma 1. Okay, so here's part of the line. Part of the graph, I should say. Okay. Then we have negative x plus 2 between 1 and 2. All right, well, that's, again, we can go right here, and we go negative x plus 2, negative x plus 2 table. And then only between 1 and 2, so I've got 1, 1, and 2, 0. Okay, so it's just that little piece of the line there. And then the next part is y equals 3 when x is greater than 2. Okay, so where is y equals 3? Imagine this. You're not worried about the top part. You're not even worried about this. If you just wanted to graph y equals 3, just that piece of this, right? What would it look like? Well, you'd go up 1, 2, 3, and you would graph a horizontal line right here all the way across. But we only want it when x is greater than 2, so we're not going to start that line until we get to 2. Put an open dot there. And it's going to go off to the right like that. Ignore this little tick mark that went off above the open circle. Okay, so that's how you graph piecewise defined functions. You go by each piece, and you pay attention to, these are called the constraints over here. Okay, so you pay attention to that and only graph the pieces of these graphs on the left. That's piecewise defined functions.